Okay. MAWP is a cloud-based pressure vessel design software. It's a vision to present a way to design pressure vessels which is simple and easy to use and very in tune with an engineer's way of working. Often we've come across software which is designed to make it easy to design, to do program, but it's rarely that somebody looks at it purely from the perspective of an engineer and tries to integrate everything which an engineer would want, and that's what we've tried to do. So we can do a lot of things in the software which would complete the entire design processes, right from modeling right down to getting the drawings out of it. So we've tried to make it easy to design the vessel in 3 dimensions. You get a visualization of the vessel as you design it, which makes it intuitive and very easy to understand what is happening with the data that you're entering. It's not just spreadsheets or some interface where you have to wait a long time to understand what exactly the dimension that is being entered does to the design. We've tried to make the interface present options in a sequential manner, which makes it easy to understand, and hardly any training would be required for creating designs. In addition, after the 3D design is done with all the dimensions and the details of vessels of materials, the report, ASME design report, as well as the 2D drawings get generated through the software. So the 3 things that we've tried to do is to make it a very powerful but simple user interface, complete the end-to-end design completely in the software, right from the design right to the drawing. And we want to make it very quick and easy to do so that you don't spend much time designing, but rather you're able to respond to client requests. So we'll move on to the software itself. At any point of time, please step in if you have a specific query, then I'll be able to handle it right at that time, or we can wait for the Q&A at the end of the session. So this software runs in a browser. The app is running in the cloud on a Google server. The app is presented through the browser, and one can log in from a standard browser page. So I'll just log out and show the process. So you go to the app web address, which is app.mawp.ai. And this is the first screen that one sees. We enter our username and our password and just log in. On logging in, we get a dashboard which presents all of the vessels which have been designed so far. All of the vessels are available, so it's easy to shortlist a specific type of vessel based on your text searches, or you could even use on project names, and the number of options available will be reduced. So it's easy to find similar vessels which have been designed across the timeline, and none of your designs would ever get lost, or it would not be hard to locate. In this case, I want to have an ammonia storage vessel. So I just click, put AMM into the search bar, and I've shortlisted the vessel which I'm looking for. Just click the name and you go to the design parameter form. So here we've all the basic data which is used to specify the design can be entered, from the design pressure right down to the type of radiography which is used for the joints. In this case, I'm using an ammonia storage vessel as a sample. So the pressure is 2.2 MPa, which is around 22 kg per cm square. Design temperature is 55. There's a corrosion allowance of 3 millimeters. The density of the fluid is 652 kg per meter cube. And I'm using the ASME Section 8 Division 1 code. So details of the location, wind velocity, the seismic zones, any live load being impinged on the vessel, and any insulation if required can be entered. And once that's done, we can go to the 3D design screen. So in the 3D design screen, we have the menu of the various types of objects which can be created on the vessel itself, and some utility buttons to generate the design report or to create a drawing. To go back to the project inputs, and basic input is also available. So you can go back to the project input and see the basic details which we have entered for the name of the vessel, duty, the client name, back to the basic input, and then back to the geometry input. So everything is easily accessible directly with ease from the main screen. So the user interface is also very quick. One can easily select any of the items directly from the screen. Just click the item and you get a small edit bar where you can select the item to be edited and change its dimensions. In this case, let's try and see what it would be like to edit the shell. So after clicking on the shell, we use the edit icon and you get a menu bar which gives you all the options for the design of the shell. You can enter the tag, or you can change the name of the item. You can click and you can see the various, the length of the vessel and its inside radius. You can switch the type of specification to inner diameter or inner radius, depending on how the data can be easily understood and the direct entry of that particular value. There's a material screen where we can decide the type of material we can use. If we want to switch to a different spec, it's easy to shortlist from the ASME database. In this case, I'm asking for all specifications which have 516 in it. So I've got all the variations and we've selected 51670. Stainless steel materials and other options are available as well. So I'll just show you some of the options in the search screen. So you get all the different types of stainless steel materials in addition to the existing material. So the full ASME database has been entered and is available to select from. In this case, I'm not going to change the basic material, so we go on. Then the software automatically calculates the minimum required thickness, and it can be changed, and a higher thickness can be selected if required. And then we finish, or you could get a quick report of what the bill of material is going to look like. So we have our main shell made of plate, the specification, and these are the developed lengths of the material, its thickness, and what the weight is going to be. You can also have a quick view of the ASME details. So you can see that the report is going to look like this. You can get the design pressures and the specifications. The individual calculations are presented in individual tabs, and it's very easy to get a quick idea of the particular component one is designing. Okay, right. Just sometimes the software needs a refresh, and because of the browser, it's easy to refresh, and the work never goes away because it's saved in the database. Even if the connection were to drop to the server, your internet connection goes down for any reason, once you restart, you get back to your same session at the same point that you were. So now, I'll just generate a design report, the complete design report of the vessel. So here we have the entire design report, the title page, details of the project, the basic inputs which have been entered, volume calculations, a weight summary, static head calculations, then individual calculations for each of the components, the shell, the ellipsoidal heads, and the nozzle which we have designed. Now, if we want to add another component, for example, we want to add a flange onto this nozzle, we can click the flange icon, and it's a standard flange. We'll take a well neck type of flange, and we select the nozzle, which is the nozzle 1. It's a forging, and software is suggesting a class 300 flange, and at this particular projection from the center of the vessel. So we say finished. Oops. Okay. Okay. Yeah, okay. I think there's a slight mismatch between the diameter of the nozzle and the one which I've selected. So I'll just go back and change the nozzle into a standard pipe. So I'm editing it. I had earlier made this nozzle with a plate, so the diameter may not exactly match. So I'll select a standard pipe. And okay. 106 grade B material, and we'll select 24-inch nozzle. Give it a in case reinforcement pads are required, they can also be added. And so we have a reinforcement pad on the nozzle. So now I'll go back and add a flange onto the nozzle. Okay, and we've got our nozzle on our flange. Now we'll also generate a 2D drawing now. So the app can also run in full screen mode, so you can maximize the screen area. The browser is maximized to the full screen area, and you get more area to view the design and the forms. So here we have the details for the drawing. So right now we are getting the third angle and with an A1 size paper. So in the title block, we can add the details which are required. So in this case, let me add my initials. And we have a drawing name. Okay. Even revisions can be entered into the block. And in case you want to even add a second revision and say that First Amendment. These are not controlled. but they can be added to complete the drawing. We can decide which details we want to have on page 1 of the drawing, and notes can be added into the drawing. Okay. Design data from the main model will get entered into the drawing, and it can be edited in case you require to do that before putting it onto the drawing. The bill of material also is presented. This can also be edited to add any remarks. We get our nozzle schedule, and we also have a MOC table, which summarizes the materials used for each type of component. So once we've done that, we can create the drawing. So the software uses the 3D information available to generate the drawing. So the drawing is created on the server, and it's downloaded to the hard disk. So then it can be opened in any 2D package. So I'm using GraphSite right now. And we have the drawing which has been generated from the model. So we've got our saddle, our shell, 2 ellipsoidal ends. We've got our design data block, our nozzle schedule. All the details, typical details, are presented on the drawing, and along with the bill of material of the vessel. It also has the title block, and we have our notes, which we had entered, was also presented. Now we're using the feature for having a text block in the drawing, so you can easily add more notes into the drawing after that, or you could even have a whole set of notes all together, which can be easily edited. Right. Yeah. So right. So that, in a nutshell, is how MAWP works, and we can keep adding nozzles and create very detailed vessels by keeping adding components to it. Yeah, the software has, we have to design the components in the software. It doesn't have a module to accept 3D from another package. So you have to use the tools in the software to create the 3D model, and then you can generate the bill of materials and drawings and the design report. Does that answer? Yeah, standalone fittings. For example, if a nozzle were to be analyzed, I would just create a simple shell and put a nozzle on it and analyze it. As such, I can't do a separate flange or a nozzle, would not be possible. But I would make a very simple model with just a simple shell, and then add a nozzle and a flange or something to it. So let's say I want to start from scratch. So I remove everything from the screen. So here I'll just redo that. I remove all the components from the screen. So I have a blank slate. So I use the icons on the left menu bar to select which design item I want to make. So if I use the left icon, I get my shell design wizard, and I can select a vertical or a horizontal shell. I can go to my different design tabs, or in case I know what exactly I want to do, I have another view version where I see my whole options in one single screen. So if I know what I'm doing, I could set my inside radius, and then I change my length. I could change my material to, let's say, 304, and then I say finish. So using all those options, it's now made my shell out of 304 SS. Now to have a new component, I have to use one of the icons on the left menu bar. And when I click the icon, I get my wizard. So the wizard allows me to enter all the details for this particular component. So in this case, I can change specific details like the service. And I go to the individual design menu screens. And in this case, I'll change my material for the nozzle as well to a stainless steel. I'll change the diameter of my nozzle. Let's say I take 6 inches. And in this case, I won't, let's see if I need a, yeah, I need a reinforcement pad. So I'll put in a reinforcement pad plate. And yeah, so I've got my nozzle and reinforcement pad along with my shell. So I save my design. Yeah. And yeah. Did that answer your question? We have not incorporated quick opening closures. We just have standard flanges, and we can use a blind flange to close a nozzle. So for example, if I put a flange onto this and yeah, I could close right now. I can use blind flanges, but quick closures are not available. These are custom components which we haven't started as yet. Right now, only some basic components are, the very basic components are available. Specialized components are still in planning stage. Yeah. Yeah. For example, we do have an end where we could have a flat plate closure. So I say dished end, but instead of a dished end, I really want to close it with a flat plate. So I have an unstayed plate, and couple of weld details are supported for this plate, but in this case, it's the design pressure is really high. So I just use it for a simulation, so I can close it off with a plate. So the software does allow some automatic resizing. So for example, if I wanted to reduce the size of this to a smaller one, it would automatically resize some of the components and allow me to do very quick editing on the screen. So that's an option which is available. Yeah. We could put a flange onto the shell, body flange, and close that, or use a directly welded flat plate. So some of the other components which are right now available in the prototype stage are we've got tube sheets. So in case you wanted to fit a tube sheet. Okay, let's see if I can do it. So yeah, I just have to adjust my outside diameter, but it automatically calculates and gives you a fully tubed tube sheet into the design. There was one which said, is there a welding detail for the shell alone? So we have the detail of the shell joint in the drawing. So we have this as a typical joint for a plate, and it gets welded with a single side penetration joint. So we're putting in the other joints as well. So soon you should have options to put in double side and different angles and depths of weld on both sides. Right. This was not meant to be a tutorial as much as a demonstration of the capabilities of the software. So thank you for your time. And if you have any questions, please email us, and we'll be happy to reply, as well as do any specific simulations, or if you want to check that a specific design can be done, we'll be happy to respond. Thank you so much for your time and being here, and I hope it was useful. Thank you.